The top, we're going to talk about sequences today. A sequence is a list of numbers that are occurring in some specific order. There's a pattern to it. An example of a sequence would be like 2, 4, 6, 8, 10, 12, right? They're occurring in some sort of a pattern there. The generic form for a sequence is going to be written as a sub 1, comma, a sub 2, a sub 3, a sub 4, and so on, right? That just tells you what term it is. So 2 was the first term listed here, so it would be denoted as a sub 1. 4 was the second term, so it would be a sub 2, so on and so forth. So a sub 1, like it says, is the first value, and then when you get all the way to the end, we'll see it written as a sub n, denoting that it could go on infinitely, right? The explicit form of an equation for a sequence is an equation for each value as a function of n. So a lot of times they'll give you like a rule that you follow, and then this would be the rule here. To find a sub n, so this would work for any number in your sequence, whether you're looking at number 1, 2, 3, 4, 5, whatever in your sequence, you would just plug that number in for n to figure out what the actual term of that sequence is. So, generally, unless they specify otherwise, your sequence should always be starting with some first term as 1. So like it says here, our first term is always going to be 1 unless they state otherwise. So if they don't say anything, you can assume that your first term is going to be 1. So on example 1, they give us the sequence -12, 6, -3, 3 halves, and they want us to fill in the blanks. So first they ask which term, or what is the value of a sub 1? Well, remember, this should be the very first term in the sequence, right? So what's our first term? Right. Then they ask for a sub 2. What would that one be? And then what's a sub 4? 3 halves. Yep. Okay. And then like I told you guys, oftentimes they'll give you some rule that represents how to find any term in that given sequence. And here they said find the first 5 terms using this rule. Again, if they don't tell you where to start, where do we always assume we start? 1. So we got 1, 2, 3, 4, and 5 will be what we are using for the nth term of the sequence. Then it wants us to figure out what its actual value would be at each place, right? So all I would need to do is substitute in this number for n into the rule to figure out that value. So for this first one, I'd have 2 times n, which in this case is 1, plus -1 raised to that n power, which again in this case is 1. So I'd simplify here. This is really just 2 minus 1, right? So we get 1. So the first term of this sequence would be the value 1. Okay, I would do the exact same thing to find the second term, but instead of the number 1, I would now be plugging in the number 2, right? So I'd have 2 times 2 plus -1 to the second power. So anywhere there's the letter n, I plug in the number 2. So I simplify. Here I'd have 4 plus 1, right? Because when I square a -1, I get a positive. So this one would be 5. So the second term of my sequence should be 5. I'll do the same for the following 3 terms. So I'd have 2 times 3 plus -1 to the third power. 2 times 3 is 6, right? And -1 to the third power is, right, So this would be 6 minus 1, which simplifies to 5, right? So the third term of this sequence is 5. Okay, and then the same with 4. 2 times 4 plus negative 1 to the 4th. Well, 2 times 4 gives us... And what's negative 1 to the 4th power? Positive 1. So this time it'd be plus 1, right? So we'd get 9. Okay. And then for our fifth term, 2 times 5 is... And negative 1 to the 5th power, right? So we would get 9 for this term as well. Okay? All right. So if they give us the rule, pretty easy to figure out any term in the sequence, right? Doesn't matter which term they ask you for. If they asked you for the 100th term, all you'd have to do is go plug in 100, right? Okay. It also says here that some sequences are written in what we call recursive form. This form of an equation is going to give you the first value of that equation to help you determine later values. Okay, so they'll only give you the first one, and then you can use that to figure out the second one, and whatever the second one is can help you figure out the third one, right? So they'll give you a sub 1, this will be given, and then your a sub n, just like before, will be some sort of rule. Obviously that rule can change, right? Could be 2n plus 5 to the third or something like that, right? It could change every time, but it's some sort of rule. The only downside here is that unlike this one, where they could tell you find the 100th term, and you could just go plug in 100, when it's in this recursive form, then you have to know the term right before it to find that term. So if you want to know the 100th term, first you got to know the 99th term, okay? So for example 3, again, it tells us to find the first 5 terms, but this time this is our given and our rule. So we were given the first term, so I already know the first term is 2, right? They told us that. But if I want to find the second term, I have to use that in order to find the second term. So to find a sub 2, my second term, then that's going to be 3 times a sub, the term we're looking at, which is 2, minus 1, plus 1. So this would really be 3 times, what is 2 minus 1? 1. So I'm really just looking at 3 times the first term plus 1. Well, they told us our first term was what? 2. So this would really just be 3 times 2 plus 1, which is going to give us, so our second term must be 7. Okay? And now that I know the second term, I can use that to go find the third term. So if I'm looking for a sub 3, that'd be 3 times the term I'm looking for minus 1 plus 1. Okay, well, a sub 3 minus 1 means I'm actually going to be plugging in a sub 2, right? And what did we figure out that a sub 2 was? 7. So I can plug in 7, which is going to give me, right. So our third term would be 22. But I wouldn't have been able to just find the third term right off the bat, right? I had to know the second terms to help me find the third term. Okay, same for the next two. So if I'm looking for the fourth term, then I'm going to need to use the third term. So I'm going to multiply 3 times what for this one? Right? So we end up getting, all right, and then same for that fifth term. So what are we going to multiply 3 by this time? All right, so 3 times 67 plus 1. What's that going to give us? What is it? 202. Good. All right. So if it gives you a rule where you're just using in, like the first one, then you can find any term they ask for right away. But if they give you a recursive form, which is going to be written as n minus 1 in the rule, then you have to know the one right before it in order to find the one that you're actually looking for. Okay? All right, flip it over onto the back. We're going to go over factorials real quick. So first of all, the definition of a factorial is that it is the product of an integer and all integers below it. So, for example, 5 factorial would be the product of 5 and all the numbers below it. So 1 times 2 times 3 times 4 times 5, right? And if you multiply all those terms together, it tells you would get 120. Okay, there is a special case, and you can always check this in your calculator if you happen to forget, but 0 factorial, contrary to what we might think, is actually 1. So you can check. It's kind of like just like with your exponents, right? When you raise something to the 0 power, it always becomes 1. So just kind of one of those rules.
Okay.
Yeah. Okay, now it is important that we realize that when something is written as 2 times n factorial, this is not the same as 2n with the entire thing being taken as a factorial, right? So, depending on the notation, just make sure you're careful there about what it means.
The factorial only goes to n?
Yes, on the first one, the factorial is only with the end, while in that first one, it's with the 2 as well.
Okay.
All right, so for example 4, it says we're going to simplify the following factorial equations. So, when it says 7 factorial, this would mean 1 times 2 times 3 times 4 times 5 times 6 times 7, right? So 1, 2, 3, 4, 5, 6, 7. In the denominator, it has 5 factorial. This would mean 1 times 2 times 3 times 4 times 5, right? Now, if I write it out like this, I can already see some things that should divide out in numerator and denominator, right? These 1s, 2s, 3s, 4s, and 5s, they all divide out, right? So all that's left is 6 times 7 in the numerator. Well, what is 6 times 7? Right. And there was nothing left in the numerator except that understood value of 1, right? So just be 42. Okay? Same idea for part B. On part B, we've got 2 factorial, which would mean 1 times 2, right? And then we would multiply that times 6 factorial, which would be 1 times 2 times 3 times 4 times 5 times 6. And then in the denominator, we've got 3 factorial, which would mean 1 times 2 times 3 times 5 factorial, which would mean 1 times 2 times 3 times 4 times 5. Okay? And again, I've got some things that will cross out. 1 and 2 cross out here. We got 1, 2, 3, 4, and 5 that cross out over here. So what are we left with in the numerator? 6. And in the denominator, all that's left is 3. So this is simplifying down to just 2. All right. Okay, So for example 5, it says write the first 3 terms of this sequence. Well, again, if they don't tell us where to start, we always start with what number? 1. So if I want to find the first term of the sequence, I'm just going to plug in 1. I'll have 2 times 1 in the numerator over 1 factorial in the denominator. Well, 2 times 1 is going to give us 2, and 1 factorial would just be 1, right? So this is just 2. So our first term would be 2. Okay, same idea if I want to find the second term. Second term, I'm going to plug in 2. So I'm going to have 2 times 2 over 2 factorial. Well, 2 times 2 would be 4, and 2 factorial means, which would be 4 over 2, which simplifies to just 2. Okay? All right, let's look at that third term. A sub 3. This would be 2 times 3 over 3 factorial, all right? So 2 times 3 gives us 6, and in the bottom we'd have 3 times 2 times 1, which is also 6. And 6 over 6 is just 1, right? Okay. All right, last thing we're going to talk about on these notes is summations. Summation notation often uses this variable called sigma, and it means that you're going to find the sum of the given function's output values. Basically, you're going to add up all of these outputs that you get. So like we got these 3 as outputs. If I asked you for their summation, you just add those numbers up, okay? So on example A, it says to find the following sums. Okay, the way we know where we're starting and ending, right? How far into the pattern do I go? The number right here where it says I equals, that's where I start. So I start at 1. The number on top tells me where to stop, okay? And I just go plug those in to the rule. So the first number I'm supposed to plug in, they said was 1. So I'd have 2 times 1 plus 1, which would give me 3. Okay, and I just go in order until I get to where they told us to stop, which was 4. So now I do 2 times 2 plus 1, which would give me 5. And then 2 times 3 plus 1, which would give us, right? And then finally, 2 times 4 plus 1, which would give us 9. All right? And then I just total these up. So when they ask for the summation, all I'm doing is totaling up my outcomes. So 3 plus 5 plus 7 plus 9. What would that give us? So our sum is 24. Okay? So you can solve them by hand, especially when it doesn't ask for too many that you find. However, there is also a way you can do this in your calculator, okay? So the way you do it in your calculator is you press the button that says Math, and you scroll all the way down to where it says Summation. It's pretty far down the list. Okay, everybody find that button, Summation? Okay, so then it should pop up with the sigma, and it'll have like a box equals a box, and then a box up here, and then a box here, right? Once you press summation. So remember, it's going to be some variable equals where you're supposed to start. You do not have to use I. I would use x because that's the easiest variable to put in our calculator. So we'd put in x equals, where did they tell us to start on part B? 0. So down there I'd have x equals 0. And where did they tell us to stop? So up here above sigma, I'd put 3. And then I just plug in the rule. So 4 times whatever variable you used at the bottom, we'd use here. So I'd put an x cubed there. Which is the same thing as your calculator finding 4 times 0 cubed, 4 times 1 cubed, 4 times 2 cubed, and 4 times 3 cubed, and adding them all up. That's what your calculator is doing, right? So when I put that in, what did we get as our summation? Right. So whether you do it this way or whether you did it this way and you got all of your values and added them up, either way, we get a summation of 144. All right. So in your calculator, that's math summation. All right.